Okay, so we're talking about lesson 7.3, special products of polynomials. And anytime in mathematics when you see the word special, this means there's a pattern. So special just means pattern. That's all you got to worry about. So if there's a pattern to something, usually that makes it easier. And don't forget the word products. That means to multiply. So we're finding patterns of multiplying polynomials. Basically, that's what we're doing today. The essential question are, what are those patterns? And learning targets, use the square, sum and difference pattern, and use this to solve real life problems. So, no new vocabulary here, just finding some patterns and things. So if you take a look at this right here, you take this right here and you square it. You take this right here and you square it. And then you take the two and you multiply them together. So A times B is AB. And then you multiply that by 2. So you get 2AB. And you're good to go. So take a look at this example right here. I'm going to write it off to the side just so you can see what I'm doing here. And x plus 5 squared. So you're going to take the first term and square it. You're going to take the last term and square it. You're going to take the 2 and multiply them together. So x times 5 is just 5x. You're going to take that and multiply it by 2, and that's going to be 10x. So here's why this works, and it's so darn cool. So if you have x plus 5 and x plus 5, and you make yourself a quick little box, you'll see you have x squared, 5x, 5x, and 25. Well, what are you doing with these? You're combining them, you're adding them together. They're exactly the same, so you could just take this times 2, or you could say 5x plus 5x. Either way, you're multiplying by 2 or just adding the 2 together. So if you wanted to do that, you could say 5x plus 5x is 10x, or multiply by 2. So that's how this works. Now the only difference between these and the other one here is the fact that this has a plus, which means the answer has a plus right here. This one has subtraction, so the subtraction is right here. So make sure you're paying attention to those signs. So if we're ready to try them, let's give it a try and see if we can figure this out. We have the first term. Oops, sorry, you can't see that. We have the first term right here, so we're just going to square it. So that's 3x times 3x, which is 9x squared, and 4 times 4, which is 16. Notice I'm leaving a space here. So I'm going to take 3x times 4, so 3x times 4, which is 12x. 12x plus 12x, or 12x times 2, either way you want to go about it, is 24x. And you're done. And instead of doing the whole box, you actually took care of it the different way, using a pattern. So let's try this again. So you have 25x squared, 2y, so that's going to be 4y squared. And then 5x times negative 2y, so 5x times negative 2y. I don't know why I just put that in parentheses, but that's negative 10xy. So negative 10 plus negative 10 is negative 20. Or you could just say negative 10 times 2, which is minus here. Notice the minuses, 20xy. This one, x squared, 49, 7x, 7 times x is 7x, times 2 is 14x. Voila. That easy, and you saved yourself some work. So go ahead and give the ones down here a try real quick. Try to pause the video and try these before I go over them. See if you've got this. In 3, 2, 1. Okay, so the first one would be 49x squared. 9 and 21, so it's negative 21x times 2, which is negative 42x. 16x squared, y squared. 4x times y is 4xy times 2 is 8xy. Check your work as you're going. Notice the subtraction signs here. This one would be addition. So 9m squared, n squared, 3mn. When you're multiplying 3m times n, you get 3mn times 2, that's 6mn. And you're done. Hopefully you got that pattern down. Next one's even easier. So this is called the difference of squares. And the difference of squares, you can see that they're different. You got a plus and a minus. So difference, sum and difference patterns. So this didn't quite print out just right, but you can tell what it says. So if you have the difference of squares, take the first one, square it, the second one, square it, and put a subtraction sign between them. Again, take the first one, square it, the second one, square it. And by what I mean by square is multiply it by itself. Oops, sorry. And put a subtraction sign between them. So this one here, I should say A right there. You just square it, t minus 25. 9x squared minus y squared. Okay, you ready to try this? Try this, pause the video, and we'll go over the answers in 3, 2, 1. X squared minus 100, 4x squared minus 1, and x squared minus 9y squared. Hopefully you got all three of those. The reason why this works is because you're going to basically be canceling the middle. I didn't go over that. I probably should. So you have your 4x squared and your 1, and that's perfectly fine. But this is going to be minus 2x plus 2x. So what happens? They basically cancel, and all you're left with is the outsides. So real quickly, this problem, a combination of two genes determines the color of a border collie's coat. So this problem is here in its entirety. Basically, you're using a Punnett square. It's right here, Punnett square. And a Punnett square is used a lot of times in biology, but it's also a quadratic. So if you have the parent with black and red and the other parent with black and red, you could have black and black patches, black and red patches, or just red and red patches. And in what combinations would you have those? So if you're writing an equation, it's right here. And you can see from here the answer as to how many of the puppies would potentially have just black patches, black and red, or just red patches. So you can try this problem down here if you like. You don't have to, but I'm going to make this recording a little shorter than others. So yay for that. But go ahead and give it a try if you'd like. And pretty much the same type of answer here, except for different looking puppies. All right, guys, talk to you later. Let me know if you have questions.